All right, we're back. We're on page 64. We're dealing with trig functions and inverse trig functions. And honestly, this page looks a little intimidating. So we're going to do some problems that are like, I don't think you run into these in the real world really, but like you can just do them. So let's see if we can do them. So the first one, the work is kind of like typed out for you, but none of the solutions are typed out. So if you look through here, it's like these are going to collapse together. And then, because you're going to find the secant of a ratio. The secant of a ratio, no, you're not. You're gonna find the secant of an angle. Inverse sine is an angle, right? You're finding the secant of an angle. That gives you a ratio. Then you're gonna do the cosine of the inverse tangent of that ratio. Inverse tangent of a ratio is an angle, doing the cosine of an angle. That's gonna give you a ratio because the cosine of an angle gives you a ratio. Then you're gonna do the secant of the inverse sine of that ratio. The inverse sine of a ratio is an angle, right? So then you're going to do the secant of that angle and get a ratio. Okay, I think I'm saying this right. If I'm not, I don't know. I mean to be. And then we're going to do the sine of the inverse tangent of that ratio. The inverse tangent of a ratio is an angle. We're doing the sine of an angle. That's why they're going to collapse together. So I feel like right there I just won the video by getting through that. So let's see if we can do this. So the first thing we're going to do is we have to deal with this. So I'm going to draw a triangle for that. A bigger triangle. Oh my God. What? I thought that would stay a right triangle if I tried to like drag one of the things, but not the case. Okay. So sine is 1/3. 1, 3. So the missing side here is radical 9 minus 1. So radical 8, not rationalizing. That's crazy if you do. We're simplifying the radical. Simplifying a radical called rationalizing? I don't think so. I'm not simplifying that. This would be like our theta 1, right? So now I need secant of that. So secant of that, and then all of these, the answer I get is going to go on this line in the blank. So secant of theta 1 is 3 over radical 8. So let's write in here 3 over radical 8. All right. Next thing we're going to do is we're going to deal with, so what colors are you? Should I try to color code this all the way through? I mean, I can try, but it's a struggle. All right, so we're dealing with these. I'm going to draw a triangle for this. So I might end up moving my triangles like at the end to like make my work do it. There we go. Okay, so the tangent of theta 2, let's say. Tangent of theta 2 is 3 over root 8. So draw that. So then the missing side is the square root of radical 8 squared is 8 plus 3 squared is 9. So radical 17. Now I need the cosine of this angle. The cosine of theta 2 is radical 8 over radical 17. And I'll show you on the calculator how we can check like each and every step, which is probably not a terrible idea. Next up, we're doing this. All right, so let me find a different color. There are like so many colors, but not that many that I like to use is really what I suffer from here. So new triangle. Let me move this one over. Get out of the way. All right, new triangle somewhere. Gonna be right triangle. And so the sine of theta 3 is going to be radical 8, radical 17. What's nice is the radicals like keep the sides a little smaller. So this is going to be radical 17 squared is 17 minus radical 8 squared is 8, which is radical 9. So actually just 3. So I need secant, right? So cosine is 3 over radical 17. So secant is radical 17 over 3. So that's going to go here. And then these, what color are you? I'm not sure what color that is. I think that's, yeah, this. All right. So we draw one last triangle using some color. That's the same. That, by the way, is the marker equivalent of that highlighter that I used, which I think is a little weird. They're very different. I mean, I acknowledge that a highlighter by its nature would need to be a different color, but so tangent is radical 17 over 3. So then this will be the square root of 3 squared is 9 plus radical 17 squared is 17. Radical 26. And this is theta, what are we on? Theta 4. So we want the sine of theta 4. So that's going to be radical 17 over radical 26. All right, I think we navigated that. I think that went okay-ish. So I'm gonna check it on the calculator. One shot. We're gonna one shot this thing. Let's see. So it's gonna be, this takes a while. Sine, especially if you type it wrong. Sine of the arctan of the secant of the arcsine of the cosine of the arctan of the secant of the arcsine of 1/3, which gives me that. That I think is the rationalized version of radical 17 over radical 26. Boom, got it. Man, that's like it's a real accomplishment to get these. So if you get it wrong, what you can do is like do it a piece at a time, right? So the first thing you would want to do is this, and just like see, did you get the right answer? So that didn't work at all. What am I trying to do here? All right, you know what? I'm just going to type it. Do it a piece at a time, right? Secant of the arcsine of 1/3. Check. Did you get that? We did basically get that. So then do the secant of the arcsine of whatever. I don't really know. Oh no, cosine of the arctan of 3 over the square root of 8, and see if you get. The problem that we're running into here is it's rationalizing everything. It's maddening. But you can check it a piece at a time and just like go through and see if you're getting it as you go. I'm actually just going to do the next problem, I think, in the notes in this video, because no point in making another. Well, hopefully there's no point. The danger here is that I mess this up and then it's like, oh, now I got to go back and do the whole thing again, which I really desperately don't want to do. I am, however, going to do my highlighting thing because I kind of like this. To here. Maybe I'll try to use the corresponding mark. I'll use the same pen as the marker. This is fewer steps, right? Yeah, it's one fewer. But also nobody wrote out the work for you. So the first thing we're going to do is I'm going to end up finding the tangent of the sine inverse of the cosine of the tan inverse. And then these are going to collapse at the same time. So now I need to find out what I'm doing. So I'm going to draw a triangle. I'm using the same colors, so we'll see. Draw a triangle. In that triangle, cotangent is 3/5, so tangent is 5/3. 5, 3, square root of 25 plus 9, square root of 34. So I want, that's like theta 1. I want to find secant. So the cosine is 3 over radical 34, so secant is radical 34 over 3. And then let's close a lot of parentheses. 1, 2, 3, 4, I think. 1, 2, 3, 4 open, 1, 2, 3, 4 closed. All right. So now we're going to have these go away together and these go away together. So we'll have the tangent of the sine inverse of whatever this evaluates to, right? So now I got to draw a new triangle, and I'm going to use basically the same color, or try to. So we go here. I mean, this is like a good idea, this color thing. In my mind, the colors and the highlighters don't look as much alike as maybe they actually do. They look more alike, I think, on the iPad than they do on like the Zoom recording of it, which like, that's not great, but what are you gonna do? All right, tangent is radical 34 over 3. So the missing side is radical 34 squared is 34 plus 9 is radical 43. So this is theta 2. And so I need the cosine of that. Cosine is 3 over radical 43. And then close, close. And then finally-ish, we're doing this. So we need a new triangle. that uses, what color are you? This color. New triangle. And for this triangle, if this is theta 3, sine is going to be 3 over radical 43. So this is interesting because it's like basically the same triangle, but like we shifted the sides around, which is interesting. I mean, you look at what you're doing. You're doing the tangent of the sine inverse of the cosine of tan inverse. Feels like something's going on there. So here, I mean, I know that the missing side is going to be radical 34, which is 43 minus 9, square root it. So the final answer here is, what's the tangent of that? Tangent of theta 3 is 3 over radical 34. So 3 over radical 34. And I would direct your attention, if I may, back up here. Isn't that kind of interesting? We like took a reciprocal, basically. We did like a cotangent sort of thing, essentially. Let's see if we got it right, though. So that, I mean, that's going to be embarrassing. If we trying to draw conclusions on false assumptions here. So we got to type this: tangent of the arcsine of the cosine of the arctan of the secant of the arc cotangent of 3/5, which gives me 3 over radical 34. Nailed it. All right. I'm gonna go back to the notes just because I like to end on the notes, but we are done. Also, it's getting really dark out in the world. I think it's gonna storm, perhaps. Very humid. It would be nice if it were to storm. So anyway, there you go. I don't think you run into these in the real world all that often, but like you run into them all the time when I'm making problems. So here's kind of how I came up with the problem. Not exactly, but you can use graphs to work out like what values of x are you allowed to start with. So on your calculator, if you try to graph this, which I think you should try, the graph is like really surprising. So try to graph that, see what you get, and then I'll be back in the next video and we will talk about it. So I will see you then.